Okay, let's solve another one. This one's 2 cosine squared plus cosine minus 1. And let's look at it. And it's going to factor 2 cosine and cosine. If we put a 1 and a 1, make this a positive 2 for the outer and a negative 1 for the inner to get our middle term of 1 cosine. Set your two factors equal to 0. This becomes 1/2 and this becomes negative 1. Cosine is positive in first and fourth. Would be negative 1 on the x-axis. Cosine x over r. X has to be negative 1. That's on the x-axis. So the first and fourth, when is cosine 1/2? 60 degrees or pi over 3. The fourth quadrant, 2 pi, which is 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. And remember, this was on the x-axis, so it's just pi. These are the 4 solutions for this particular problem. On this problem, we've got sine x equals cosine squared x. We've got 2 different trig functions. That presents a different situation. Cosine squared needs to be written in terms of sine squared, since it's much easier to change the squared term than the linear basic term. Remember that cosine squared x is 1 minus sine squared. So we simply go and we replace this cosine squared with 1 minus sine squared. So this is your new equation. We take this sine squared, we move it over, and this is what we've got. Well, this doesn't factor. It does not factor, so we're not going to go through the quadratic formula or anything like that with that. We're going to go to our calculator now. All right, so let's look at the calculator. And what has been put in here is the sine squared plus sine x minus 1. And you want to find the areas in which this is between 0 and 2 pi. 2 pi is a little more than 6. It's not this far over. So this is one solution, 0.66. The other one is 2.475. So those are the 2 solutions. And then I also looked at it like this. Where did these 2 intersect between 0 and 2 pi? 0.66 and 2.45. So we got the same answer either way we did it, whether when we solved it all the way for 0, which we did, or we graphed it to see where they intersect. That's not too hard to do. Okay, here is one that says cotangent and cosine. Solve for cotangent A or alpha, really, probably, or we could use A or alpha, and for cosine A. So we'll use an A. Cotangent, remember, is cosine over sine, and for cosine. So you want to replace the cotangent with that. So we move this, actually I moved that over that way. So it would be 4 cosine A minus cosine A over sine A is equal to 0. Common denominator of sine. Okay, well, we've got it over our common denominator. In order to solve it, we've got to have the numerator equal to 0. So we set that equal to 0. We see we have a common factor of cosine A. We factor it out. That leaves us with 4 sine A minus 1. That becomes 0. And we solve that. That becomes 1/4. Where is cosine 0? It happens on the y-axis, so that's pi over 2 and 3/2. When does sine A equal 1/4? Okay, this is what we get. And so that would be in the first quadrant. This would be in the first quadrant, and it's also the second quadrant. So to get the value in the second quadrant, it would be pi minus that. So those are the two values that we get from where sine would be equal to positive 1/4. So that's your 4 answers for this problem. Okay, now here's one that, well, actually it's the previous one, and you can see where they intersect here. That's where the lines intersect. So it's kind of like we verified or we checked our work. We're solving this. Okay, the first thing would be to say sine of negative x is negative sine x. Cosine squared would be 1 minus sine squared. That way we'll only have one trig function. All right, what happens here? We want to move all the terms to the left and set it equal to 0. Well, the ones actually cancel out. I think that should be an S. So we factored, we set it equal to 0, each of the factors. Sine is 0. Remember that sine is y over r. Where is y 0? At 0 and pi. Sine is 1, if it's y over r, y has to be 1, r has to be 1. That's pi over 2. So these are your answers, 0, pi over 2, and pi. If we test this with Desmos, we see that the intersections are at 0, pi over 2, and at pi. 2 pi would be the same thing as 0, so you don't label it. It's always 0 instead of 2 pi. I think that completes all of the PowerPoints for 7-1.